Okay, so again, what we're looking at here is recurrence relationship, but we're looking at a first order linear recursion with a common difference. Now, when I say difference, that usually means some sort of, it's a difference between two numbers, and it can mean you're adding 2 every time, could mean you're subtracting 2 every time, but that difference is common throughout. Okay, that's what we mean by common difference. Now, they're given a sequence here. So this sequence shown there. And what they're showing here is, let's start at the U4 minus U3 for a sec, which is 15 minus 11. Okay, so it's 15 minus 11 gives me what? Gives me 4. If I go between U3, so let's actually put numbers up here. 1, 2, 3, 4, 5. So that would be U1, 2, 3, 4, 5. So 3 minus 2. Well, even let's just go 4 minus 3. Or, no, we did that. 3 minus 2, 11 minus 7. That's going to give me 4. Then I go 7 minus 3. That is 4. You notice that as we go across, that common difference is plus 4. Okay? So we can write it in this form where we say, remember, that's our next term. For example, U2 minus the previous term, U1, gives me 4. In this case, where we're stating U1, our first term is 3. Okay, we can rewrite it the way I was showing you before and have it as UN plus 1 equals UN plus 4. So I've moved this across. Again, we're saying U1 equals 3. That's our first term. Okay, remember that can sometimes be written as U0 as well. All right, so we've got here a sequence with a common difference of D may be defined by this relationship here, sort of these two. But basically that means the same thing. In this case, what we're saying, D is a common difference, and if D is greater than 0, the sequence increases. If D is less than 0, the sequence decreases. So you can start possibly to see where some of this will come into when we're talking about financial maths. Okay. Now, I'm going to go through, what I'll do is I'll go through worked examples with that first and then come back to the common ratio one. So here's a worked example that I've got, that I've prepared earlier, so to speak. Okay. And I've got two samples, and we want to work out what that sequence is, okay, in terms of a first order relation. And so let's go, we're going to, again, let's number and go 1, 2, 3, 4, 5. So if I went, for example, I said D was to equal U4 minus U3. Okay, remember, that's in this sort of format there. Okay, let's actually write that. Let's write it again. So it's going to be UN plus 1 minus UN equals D. And that's what we're doing now. Remember, next, previous. Okay, so D in this case, U4 22 minus 17 will give me 5. What about D when I'm going equals U3 minus U2? U3 is 17, U2 is 12. Again, I get 5. Okay, let's do one more. U2, equals U2 minus U1. So that's going to be 12 minus 7 equals 5. Okay, so what we're saying here is that Remember, our first order relationship is given as un plus 1 equals un plus d. Therefore, we've found out d is 5. So I can write un plus 1 equals un plus 5. But I've got to make sure I keep the important point of saying that u1, our first term, equals 7. Okay? So, what the next question's after? It's going to be, it's a slightly, not trickier, but you got to think it through what's actually happening here. Okay? You've been given this sequence, and we've got to express that as a first order recurrence relationship. And it's not a first order because I don't have a un and a un minus 1 or something like that. I don't have two consecutive terms here that are related. Okay, so we have to work out what that is. All right, and we've told that what these n numbers are here. And so what we're looking for is basically a common difference and what our starting term is. Okay, now so if I go un u1, that n equals 1, so that's going to be minus 3 times 1 minus 2. So when n equals 1, it's minus 3 times minus 3 minus 2, so minus 5. So that's actually going to become, in this case, that's our first term. Okay? But let's keep going. I'm going to go u2. It's minus 3 times 2 minus 2 equals, that's going to be minus 6 minus 2, so minus 8. u3, so that's when n equals 1, n equals 2, n equals 3. u3 equals minus 3 times 3 minus 2, so that's going to give me minus 11, and n equals 4. Let's put a comma in there so you can see it's separated. u4, it's going to be minus 3 times 4 minus 2, so that's going to be minus 14. Now, so our sequence here is going to be minus 5, minus 8, minus 11, and minus 14. Okay, and so that's accounting for 1, 2, 3, 4 from what we've just seen before. Okay, so our common difference here is minus 3, because I'm going from minus 5 to minus 8, that's minus 3. So basically our sequence is un plus 1 equals un, because remember that's our sequence, but our difference here is minus 3. So it's a decrease in sequence. But our u1 is minus 5. Okay? And that's how you do a question like that. All right, so what we're looking at here. So but you can see that the common difference arises. It's a sequence increasing or decreasing by adding or subtracting the same number. Sometimes it doesn't happen like that. So sometimes it increase or decrease by multiplying the term by a common ratio. So this example, there's this geometric version here. I'm going 1, 3, 9, 27, 81. Okay. So your common ratio there, in this case, I'm going to go the second one divided by the first one. So that's 3 divided by 1 is 3. Then I go 9 divided by 3, I get 3. Then I go 27 divided by 9. Guess what I get? 3. So our common ratio here is 3. All right. So basically you're working out, if you're looking at this as an equation here, that's what we worked out there. you've basically gone to work out what that ratio is. You've gone UN plus 1 divided by UN, and that'll give you your R value. Okay, so this is what we've got it as here. That's that equation there, and that's what I've taken and made into that. That's what I can work out what that R value is. If R is 1, I've got an increase in sequence. If it's between 0 and 1, it's a decrease in sequence. If it's negative, it can go alternate between positive and negative. Okay, so we're up to the second set of worked examples here. Okay, I might only do one because this is going to become a bit of a long video clip. Okay, so if I look at the first one, I'm going to do this one for initially, and I might skim through the second version there. All right, so what I've got is I've got to work out what R is. Got a common ratio. So my R, remember, what happened there? Oops. It's a bit hard to... So I'm going to go, remember what R was? I said it was UN plus 1 over UN. So in this case, it's going to be 5 over 1, because that's like saying, so I said that would be 1, 2, 3, 4, 5. It's the same as so 25 over 5, 125 over 25, etc., etc. They're all going to answer equal to 5. My U1, as I pointed out, this is my U1. Okay, so how I'd write that, I'll just put A there. I would have that as UN plus 1 equals 5 UN, and where U1 equals to 1. Okay, that's our U1. All right, so the second one there, all it's really looking at there is I'm going to go, so if I go B, I'll do a first couple, I'm not going to do them all. I'm going to go R minus 6 over 2, because that's the first, the second, the third, the fourth. I've got 12 divided by negative 6, and you can see the pattern, it's going to be negative 2. What's my U1? My U1 in this case was 3, so that means UN plus 1 equals UN, oops, wrong way, equals minus 2 UN, where U1 equals to 3. Okay. So let's have a look at this last one. This is the last example here. Okay. All right. So I've got, let's look at A. So what we've got to put here, it's basically, you're looking at what number, you got n minus 1 up there. So I'm going to go UN, let's write the equation out, UN equals 2, 7, n minus 1. So it's like an index power thing up there. So when I go U1, okay, that becomes 2, 7, 1 minus 1 up there, which is equal to 2, 7 to the power of 0. And anything with a 0 index law becomes 1, so it becomes 2 times 1 equals 2. What about if I go U2? Then I go 2, 7, 2 minus 1. That's 2, 7 to the 1, so that's just 7. So it becomes 14. U3, I'm going to go 2, 7, 3 minus 1. That equals 2, 7 squared. So that's 2 times 49, which is going to be 98. And you see the pattern here. Okay. And what we're looking at here is that okay, so what we get here is we find that the common ratio, oops, I was right, ratio was ration. Common ratio is 7, okay? And U1 equals 2, remember? Because when I put n equals 1 in there, this is my first term, okay? And my common ratio is this bit here. So how do I write that? I write that as UN plus 1 equals 7 UN, where U1 equals 2. Okay, and we can see if we put some numbers in, if we put 2 there, we get 14. If I put, so I've got 14, if I put 14 times 7, what do I get? I get 98. If I put 90, etc., etc. And that's how it works. So let's do the second one quickly. Let's write it out again. Okay, the equation was, all right, so for B, it's going to be UN equals -3 to n minus 1, okay, and if I say U1, that becomes, the 1 there becomes 0, so it's again going to be -3 times 2 to the 0 equals -3. So guess what's going to be our U1? -3. All right, U2, I put the 2 in there, so it's going to be -3 to 2 minus 1. That becomes -3 times 2, so I get -6. Let's try U3. I get -3 to, so 3 minus 1 squared. So that's 2 squared. 2 squared is 4, so it becomes -12. Okay, and what we find here is the common ratio is the 2. So I've got my 2 points here, so I can now write and go, my common ratio is 2. So I'm going to go UN plus 1 equals 2 UN, but our U1 equals -3. You can see if I put that in, I go -3, 2 times -3 equals -6, which is what we got here. Then I put the -6 in there. -6 times 2 gives me -12. And again, the pattern's repeating then. Okay, thank you.